Hi everyone, my name is David Anugraha from University of Toronto, and today I'm going to present our knuckle paper titled ProxyLM, Predicting Language Models Performance on Multilingual Tasks via Proxy Models. So there are several problems in fine-tuning and evaluating language models on multilingual tasks. First, it requires high resource intensity, which means that it requires significant amount of computation and time, and requires a huge number of combinations between languages and datasets. And for low resource languages, this challenge is exacerbated by limited data availability and their exclusion from the pre-training phase of multilingual LMs. Now, one efficient solution based on previous works is to do performance prediction, which is an estimation task on how well a language model will perform on a downstream NLP task by leveraging its past performance records. To be more concrete, in this diagram, we have dataset features, which represent the dataset for training and the task we're using, and the language features, which is a language-specific representation, and model M, which represents the LM of our interest. The regressor here takes these features to predict the performance of M, which is represented by this y hat M. And the goal is to minimize the difference between the prediction and actual evaluation of model M. Now, the current limitations of performance prediction, at least from the previous works, is that most of the works performed on the same domain data. They also focus on high-resource languages only. And finally, they only focus on older language models such as Vanilla Transformer and NBART. So now we introduce ProxyLM, which is a novel framework where we try to incorporate proxy model scores on top of dataset and language features. Now here, proxy models refer to alternative models that are smaller and more efficient to evaluate, so we can obtain such performance and use it as a helpful reference on making predictions of the performance of the estimated model M here. And in our framework, we represent here, let's say we have a proxy model score for this translation, and then we use this as a proxy model scores to feed it into the regressor. So first, we have the NLPer feature, which means that we have the language features from the Euro typological database and dataset features. More detail can be found in our paper. But the main point is that for the additional features, we include distributional shift information because now we have a heterogeneous data set. And we also include the proxy model scores as mentioned before. We evaluate on 3 tasks. First is machine translation, where we include an English-centric dataset coming from MT560, MT560, and first 200 with 32 datasets and 50 languages. Another is a many-to-many language dataset, which includes Nusa translation that includes 8 Indonesian regional languages. Note that both of these datasets includes high resource, medium resource, and low resource languages, and also extremely resource languages, especially for Indonesian regional languages. And for the estimated models, we use M2M100 and NLB with the proxy models of Vanilla Transformer, Small 100, which is a distilled version of M2M100, and the estimated models version of the non-fine-tuned version, which is a proxy model because we can use an off-the-shelf without any fine-tuning at all. And for the settings, we use random, which means just you're using a random split, and leave one language out. It means that we keep one language for test and use the remaining languages for training. And another, we have cross dataset, which means that we train on the English-centric and then we test on the many-to-many performance records. And finally, we have unseen because for the pre-training language model, sometimes they don't include some languages, and we use that as part of the test by leveraging the past performance records for the languages that are included in the pre-trained LLMs. Note that these 3 settings, the last 3 settings, they are more for testing robustness and generalization. Now for the remaining two tasks, we use intent classification and slot filling from the massive dataset, which includes 51 languages, including high resource, low resource, and medium resource languages. We use Llama 3 Instruct and IA 23 8 billion as part of the estimated models, and we use proxy models of SmallLM and BloomZ. The settings, we only use random and low. Now for the results, first, keep in mind that ensemble here means that we are using 4 of these proxy model scores as part of the proxy model features. So we can see that like for machine translation, for English centric, we have 2.41 times average reduction in RMSE based on SB Blue compared to the best baseline, which is 9.39 here. And then for many-to-many, we have 1.7 times average reduction compared to the best baseline as well. So that means it is very significant that our methods improves the accuracy very much compared to the baseline, which is Anaperf and some other regressor methods. And for intent classification and slot filling, we see that there is an improvement of 1.34 times and 1.28 times average reduction in RMSE, respectively, based on accuracy for intent classification and micro F1 for slot filling. This is also compared to the best baseline. Note that small LM here is enough, while the ensemble here is second best. So that means that there are certain combinations where the proxy model features will be better compared to the other combinations. But note that in all cases, the proxy models fit ProxyLM with different proxy models always perform better than the best baseline. So in order to show the robustness and generalization, as mentioned before, we test on cross dataset and unseen. And as you can see, the ensemble here, ProxyLM, along with other individual proxy models, is always or somewhat always better than compared the best baseline, which is represented by this cross, and you compare with the triangle here, and they're way better significantly, which means that ProxyLM actually improves the robustness and generalization on performance prediction. And we also did a ablation study by investigating different features, such as using proxy models as represented by this hash, compared to not using proxy model at all. And as you can see, there's a significant gap between using proxy model as a feature and not using proxy model, which means that using proxy models actually improves the accuracy by that much. And the other features actually do not affect the performance significantly after we include proxy model. And to compare in terms of efficiency, we plot this chart or table rather, where we have a up to 37.08 times speed up compared to a traditional method, which means that we just do a traditional fine tuning and evaluate just to get a one performance record. That means that proxy models can significantly reduce computational overhead in terms of task evaluations. Now, in conclusion, ProxyLM is a framework that uses proxy models as substitutes to estimate the performance of the target model. It is applicable and scalable to a wide range of downstream NLP tasks. And as shown in the results, it significantly improved performance in terms of prediction accuracy. And we also showcases its robustness and generalization across different datasets, across different settings, across different level of languages, noise of the datasets, and etc. We hope that our presentation here can help inspire future research in performance prediction, and hopefully our work is also helpful for everyone else. Thank you for listening. See you.